Cancer. It's a big problem. Over 100 distinct diseases, each characterized by abnormal cell growth, caused nearly 10 million deaths globally in 2022. Cancer treatments include a range of options: radiation, chemotherapy, invasive surgery. But curing cancer remains a difficult, sometimes impossible problem to solve. So when it comes to the foundations of cancer research, it may surprise you to learn that things are looking up. 250 miles up. I'm Mike Antares, and this is Space for Humans. One of the reasons that cures for cancer remain elusive targets has to do with how research is conducted on Earth. Every time cells are grown, or technologies like protein crystallization are explored, you can see our other video over here, they're subject to gravity and typical cell processes. This natural earthbound order slows research down. That can mean long wait times and extensive sunk costs when researching how cancer cells behave under typical conditions. And that's where space comes in. In microgravity, cells experience more stress but less sedimentation, the settling force due to gravity. There's no force pulling them inevitably in one direction. That means that cancer has more pathways and cells experience more rapid changes in space. Studying these fundamental changes provides key insights into how cancer can be addressed. For instance, in one recent experiment, the University of California, San Diego partnered with Axiom Space to study artificial neural tissue grown from stem cells known as brain organoids. They examined tumors in these organoids during one of their missions, and after identifying early cancer warning signs, they began looking for ways to reverse the precancerous cells. This in turn resulted in developing medicine meant to combat an acute form of leukemia. Partnerships like this are a result of teams on the ground developing procedures and technologies that public and private astronauts then use to examine specific and often accelerated effects while in orbit around Earth. These experiments often mean observing cancer cells change in real time. That helps speed up the process of developing therapeutics back on terra firma. It's a high-altitude, high-reward scenario. NASA is funding other cancer research and technologies in low Earth orbit as well. Take protein crystal growth as an example. The structure of specific proteins associated with some of the nastier and deadlier cancers are difficult to study on Earth. By forming these proteins in crystals grown in microgravity, scientists produce invaluable data to help develop more efficient cancer therapeutics on Earth. Similar NASA-funded cancer research includes growing and examining how 3D human tissue chips respond to radiation and studying endothelial cells, the ones that supply blood to tumor growth, in microgravity. Of course, it's much more expensive and logistically difficult to field missions to space to study how cancer cells behave. Missions are costly. Launching all of the equipment necessary and training astronauts and ground operators how to carry out the procedures is a time-consuming process. But it's an invaluable one, since the conditions on the ISS cannot be replicated here on Earth. As America's most experienced astronaut, Dr. Peggy Whitson puts it, we gain an understanding that enables us to improve our procedures and process on the ground. We've all been touched by cancer in some way, so it helps to know that high overhead, in orbit at all hours, cancer treatment research is moving humans ahead by giant leaps. Did you enjoy this episode of Space for Humans? Does this research make you want to know more? Let us know in the comments below, and don't forget to like, share, and subscribe. Keep on checking in for more Space for Humans.